What up? Monica's here.
Milk's here too.
We're going to count some moles in formulas and equations.
Nice. So we're going to put those subscripts to use.
Yes.
Right.
So what do they mean?
Let's hop right to it.
There are many of that element that directly precedes a subscript. Oh, what's that mean, Mr. Milk?
That means that in a formula like this, it
C6,
means
H12O6.
that
Okay.
how many numbers of carbons? Well, the 6 is referring to the carbon. The number directly preceding it, before it.
Oh,
So
that's what it means.
there's 6 of the carbons.
That means there's 12 hydrogens.
That means there's a 12 of the hydrogens.
And 6 oxygens, too.
And you are going faster than the PowerPoint will go. But yes, you are doing
Yeah.
good.
Nice.
Hey.
Well, I guess it was that simple.
It really is, but we can never mess that up anymore.
No.
You have to get this right every time.
Can't screw it
Okay? I hope that was enough example. Homework's done. No, I'm just kidding.
up. But what are these? Not all chemical formulas are as simple as that one, Mr.
No, there are some more complex ones.
That have
and-
parentheses.
Yeah, and they have parentheses. So that a parentheses just means there's a polyatomic ion in there. I put a parentheses around it. Sometimes even if there's
Reference
just
table
one.
E. Gotcha.
Yes.
Okay.
And it could
It's
those
a group.
those polyatomics are a packet. They gotta stick it together.
So let's see what we do. If I
Yes.
have a parentheses, how do I count this?
Well-
There's no numbers.
There isn't. But I know that OH is my polyatomic ion. And I didn't do the numbers on this, but there's no numbers after the Na. So how many do you think there is?
1.
And there's no number after the parentheses. So how many hydroxides?
1.
1. Good.
Oh,
So
okay.
this one's easy.
So let's count them.
Okay. 1 of each.
1 sodium,
1 oxygen.
1 hydrogen.
Done. That's
Okay,
it.
but that can't be that. That can't be that simple.
No. This is chemistry. We gotta get crazy.
Oh man.
When there is more than one polyatomic, there will be a subscript
Outside
outside.
and below
of the
parentheses.
parentheses.
After, outside, and below.
Yes. So here's a
Oh.
very good,
Oh, no.
very good. Oh, you can do it, Mr.
All right, so let's count these atoms.
All right. A subscript after the Mg, it's not there, so how many?
1.
Right, because I wrote Mg, so there's got to be at least one.
Okay, there's 1 Mg. All right.
All right, so now this is where this gets very complicated.
There's 1 nitrogen.
Wrong. There are
6 nitrogens.
wrong. There are 2 packets of NO3. That
So you
2
distribute the 2 into the parentheses.
you gotta say there's 2 N's.
like it's like foil.
Yeah, just kind of in reverse order.
But you got to remember to stop in the parentheses. You don't parry that 2 all the way to the Mg.
No. There's 2 NO3s. So how many N's? 2. And I multiply the 2 times it to 3, and there's actually 6 oxygens. And if you need to write NO3 twice to get it for the first few times, go ahead. But that's really what
You mean like this?
Go ahead and show me. You'd love to write MgNO3 NO3. That might make it a little bit easier to count, but that's easier to write NO3 parentheses little 2 than writing NO3 twice. Because, Mr. Honestly, that's doing too much. That means the exact same thing. What he just wrote there on the board means the same thing.
Okay.
Or he wrote it there on the board. Or
Yeah.
there on the board.
They're on the board.
Or there on the board.
You're on
You
the
know
board.
what I mean?
All right, moving on.
So good. That's really it. So now we got to do some
Oh.
practicey ones.
So I'll let you do the simple ones, Mr.
All right.
Max.
Well, how about I'll do one of each. How's that sound? I'll do this one.
Okay,
All right. So AL.
Al. Well, there's no subscript, so there must be 1.
So there's 1 ALN. Okay.
Oh, okay. And then C. How many C's are in there?
It's not. That's actually CL. It's not a capital.
You mean
L.
I have to remember that Cl is chlorine and not Ci
Correct. It's the most common hang-up too.
because of
And-
the font?
And the subscript.
Be careful.
Yeah. And the subscript tells me that there are
3 of them.
3 of them.
Mm-hmm.
That's simple. I'm holding you to doing NaCl and BaCl2 by yourself.
Oh yeah. I want to do some.
Oh, you want to do one?
I want to do one.
Tag in.
I want to do tag team.
Tag
I'm going to
team.
do this one.
Yeah, because it looks easy. But it is actually.
I got
How's the many N's?
2.
2. Because that's
And
the
I
number
got-
following it.
5.
5 oxygens.
Mm-hmm.
That's it. Done.
We are counting moles, mind you.
Yes. Well, that if I have 1 mole of N2O5, I have 2 moles of N in that 1 mole. That's simple.
You do these ones.
Yes. Those are the you-dos.
Those are the you do's.
All right.
You better do it. You better do a hard one.
All right.
You better do the hard one.
I'm going to, to be honest with you, these are both equally as hard, so I'm just going to do this one.
All right.
All right.
How many aluminums you got here?
Well, I see a no
no suffix or
Subscript.
Subscript. I see no subscript, so there's 1.
1 mole of aluminum.
Right,
Gotcha.
but this 2 needs to go to both atoms.
O and H.
So I have O being now 2 of them, and H being 2 of them.
As well.
Because that means there's 2 hydroxide ions. Each hydroxide ion has 1 H and 1 O.
And now remember, you can have a mole of a compound. You can have moles of atoms within the compound. That's what we're counting.
Yes.
Okay.
Yes. And we're going to keep going, actually, because the numbers of moles of that compound is what the coefficient means. So in this, we're going to use this over here. This is the equation we're going to use for this page to talk it about.
We're going to convert that into a word equation.
Yeah.
So that you can see why we simplify them in this way.
Right. So the 2 and the 1 and the 2, the big coefficients, could mean numbers of atoms or molecules, but mostly it means moles. What it will never mean is
grams.
Never.
Never means
We got to use gram formula mass and a few other tricks of the trade to get to that.
You only use grams in the lab when you're doing a procedure.
Right. Or when we're getting into gram formula mass and doing that kind of
True.
stuff.
But in actual application, you only use grams when you're weighing something.
Yes.
And we're not weighing anything here. We're just showing ratios of
Yes.
one compound to the next to make a molecule.
Yes.
So
But I can take this equation now that's written right there on your screen.
and convert it into words.
Right. And so what it says is there's 2 moles of hydrogen.
That's what this is.
Yep. Reacts completely with 1 mole of oxygen to produce,
That's the arrow.
that's the arrow, 2 moles of water. Done. I just took that chemical equation and wrote it into words for you that we can read. So as a matter of fact, that's how that reads.
Yeah, that's what we chemists are hearing in our internal dialogue when we see a chemical equation.
Yes. We are
Okay.
reading this in our brains.
Right. And the reason why we make chemical equations is because, we don't like writing.
No, we
We
don't
like
want to write all that.
notation. I mean, we'd be writing paragraphs just
We're
to tell
not
you a
lazy.
couple atoms
We
react.
are efficient.
Correct.
We can say all that business with all those letters with mad less letters.
Mad, many, fewer.
That's a good way to put it. But guess what?
Next.
Oh, I thought we were over. We're not. Okay, let's do some quick examples of counting atoms and moles. So, if I have 2 moles of hydrogen, but each hydrogen has 2 atoms,
2 times 2 is
4. So it means I have 4 total hydrogen atoms
okay.
in 2 diatomic hydrogen molecules.
Okay. Fair enough. And this next one, I got 1 mole of O2 molecules. So 1 times 2 is 2. So I have 2 moles of O atoms.
Correct.
Oh, okay. It's not so bad. Why don't you take the last one?
Okay, so now I have a coefficient of 2 times the 2 hydrogens. That gives me 4 moles of hydrogen atoms.
In that water, in the 2 moles of
You said I
water
could do it,
molecules.
didn't you?
Yeah.
You gotta eat 'em.
Right, I know. I'm a hog. I'm sorry.
It's okay.
Let's
And I
keep
got 2 moles of times 1 on the oxygen, so now I got just 2 moles of oxygen atoms in that particular.
So a mole can be used to count atoms within a chemical compound or moles of the chemical compound itself.
Correct.
Okay.
It gives us a lot of information. We do a lot with it. This example is going to be a little faster.
Yep.
So 4 times 1 on the iron,
I got 4 moles of iron atoms.
done. 3 times the O2,
I have 3 moles of O2 molecules, but 6 moles of O atoms.
correct. Notice we're just saying this.
You
one.
right.
You write it all out. 2 times 2 is 4 moles of iron atoms, and 2 times 3 is 6 moles of oxygen atoms.
In 2 moles of Fe2O3.
So it just so happens those numbers actually balance out.
So yeah, this is a
Yeah.
balanced equation. So it's
It
good.
was, yes.
Yeah, that's a
So
good
and
point.
guess what?
We're done.
We done.
We got 2 pages of practice.
Yeah, there was some pieces in that homework though that I'm looking to make sure you did, even though I didn't.
Yes, that's how you get full credit.
Yes.
Now that we're in unit 4.
Yeah, like seriously, all right.
All right.
We got some practice pages, and we out. See you
See
guys
ya.
tomorrow. Okay, stop.
Trying to stop.
Close these windows.
Stop it. Stop it.